My name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 226. Please turn to it. Page number 226, and today is our lesson number 314. I in fact lied to you. The problem that we're about to solve is actually not on page 226. It is a problem very similar to the problem that we did yesterday, which is the problem that is borrowed from the problem that you see on page number 226. That equation that we see there. Yesterday we did a slightly different version of it. We converted that problem into what is known as quantitative comparison question, and we did that problem yesterday. And if you watched yesterday's video, you know I told you that that problem was very similar to the actual problem that appeared in the old GRE in the 10th edition of this book. This book contains 7 exams. Each exam has 30 quantitative comparison questions. If you're interested in practicing, if you're interested in having more practice on quantitative comparison questions, you will find solution to all of those 210 problems at my channel. Just look for the playlist which says quantitative comparison. Today we're going to do the problem that appeared on page number 328. Page number 328 on this page, in this book, problem number 12. And this is how the problem goes. We're given an equation, and this is how we're given two columns. Quantitative comparison question, obviously, but we have to compare the two quantities, which is why it's called quantitative comparison. In the first column, we are told twice the sum. It's very important that we pay attention. It is twice the sum of the roots of this equation right here. And then once we find twice the sum of the roots of this equation, we have to compare that quantity against 6. So let's see what we can do here. So the very first thing we have to do here is to find the roots of this equation. How do we find the roots of this equation? By using a method called factorization. So what we are looking here, this one has a coefficient of 1. So what we are looking for here is we are looking for two numbers such that their product is equal to positive 1 times positive 2, positive 1 times positive 2, and their sum equals this part right here, negative 3. Now that's a tricky one. Sometimes if you haven't had enough practice in this method called factorization, it's just a matter of practice. If you haven't had enough practice, you will sit there scratching your head for 2 hours trying to figure out two numbers. How can you think of two numbers that when you multiply them, their product equals positive 1 times positive 2? Of course, it's just positive 2. How can the two numbers add up to 2 and yet their sum is negative 3? Well, the two numbers are negative 1 and a negative 2. Negative 1 times negative 2 will give us the product of positive 2, and a negative 1 plus a negative 2 will give us the sum of negative 3, which is this part right here. The coefficient of x represents the sum of the two numbers. So that's it. It's negative 1 and negative 2. We're not quite done yet here. We're not quite done here. So now we know how to break this. Now we know how to break this negative 3x. We have to break this negative 3x into negative x and a negative 2x. So let's start our process. I need the room, of course, so I have to erase this part. I go at a very leisurely pace in these videos on purpose, by design. We're not in a hurry. It's one thing to prepare for the exam where you actually have to time yourself also, but right now we are learning actually the math behind the exam. Before we worry about being able to do it in a timely manner, in a reasonable amount of time, before we worry about that part, we have to first figure out how to actually solve the bloody thing. That's what we're learning here. So that's it. We're going to break up negative 3x into a negative x and a negative 2x. So this is going to be written as x squared minus an x minus 2x plus 2. That's it. The rest is very simple. What do we find common between x squared and x? What we find the common factor is x. When we take out the x, once we take out the x squared divided by x is just x. And if we take out the x here, what we are left here is 1, because x times x is x squared, and x times negative 1 is going to give us our negative x. Now we look at these two terms, negative 2x and a 2. What do we find common there? What we find common there is negative 2. Again, once we take out negative 2, what we are left here is just x. And once we take out the negative 2, what are we left here? In other words, what number times the negative 2 is going to give us positive 2? What number times the negative 2 is going to give us positive 2? The answer is right here. What number times negative 2 is going to give us positive 2? The answer is negative 1. Now, we realize that between these two terms, now this is one term, and this is another term. What we realize is that in these two terms, the common factor is this part right here, what the quantity that we see in the parentheses. So it's x minus 1, and then here we're left with x, and from here we're left with negative 2. And that's equals to 0. Now, since the product of these two quantities is equal to 0, that tells us that either x minus 1 is equal to 0, or x minus 2 is equal to 0. If x minus 1 is equal to 0, that implies that x is equal to positive 1. If x minus 2 is equal to 0, that implies in turn that x must be positive 2. There we go, we found the two roots. The two roots are positive 1 and a positive 2. And the sum of the roots is, going to be positive 1 plus a positive 3, positive 1 plus a positive 2 rather. These are the two roots, positive 1 and positive 2 are the two roots. The sum of the roots are going to be positive 1 plus positive 2. We have to write it like this because if they could have been negative quantities, in which case we have to make sure that we are adding whatever that is that we are adding here. So positive 1 and positive 2, they add up to positive 3. But we're not done yet. We are asked to find twice the sum. Twice the sum is going to be twice the sum is going to be 2 times that amount. And 2 times 3, so it's 2 times this amount is what we're looking for here. 2 times this amount is what we're looking for, which of course is 6. And here also we have 6, therefore the answer is C. That's it. That's all. Perhaps I should not have done it such a crowded manner. Let me. I shouldn't have stuck everything there. So here positive 1 and positive 2. Therefore the sum of the roots is equal to 3, because positive 1 and positive 2, sum of the root is equal to 3, and therefore twice the sum of the roots is going to sum of the roots of this equation. Sum of the roots of this equation is going to be, sum is 3, therefore it's going to be 2 times 3 versus 6. The answer is C. That's all. I will see you tomorrow where we will do the next problem, and I'm going to tell you ahead of time where the next problem is coming from, because I want you to actually try to solve it yourself. That way you get more practice. You always learn more if you try to solve the problems yourself first. Even if you have trouble doing it, even if you have a little bit problem solving it, even if you have a little bit difficulty solving it, even if you get it wrong, you will still learn more if you do it, if you try it yourself first. So here's the problem for tomorrow. Exact same setup. We're being asked to, well actually this time we're not asked to find twice the sum. It just says sum of the roots of the equation, and for tomorrow, this is for tomorrow, x squared plus x minus 380. X squared plus x minus 380 is equal to 0, versus in the second column versus 0. And this problem that I'm talking about is the one that appeared again in this book. This problem that we're going to do tomorrow, it appeared again in this book, in the old GRE, on page number 207 as number 11. On page number 207 as number 11. the question number is of a great deal of importance to us, because in the old exam, in the old GRE, which does not apply anymore, because in today's world, in the computerized version, what is known as the exam that you will take is what is known as computer adaptive. It adapts to the person's ability, whereas in the olden days, they were arranged in the order of difficulty. Therefore, question number tells you that it is considered a difficult question. The problem that we just finished, if it appears in your exam, it is a difficult question. The problem that I'm giving for tomorrow is also a difficult question. Question number 11 tells us that it was a difficult question. On a scale of 1 through 15, it appeared as 11 on the hard, in the hard territory. On page number 207, question number 11, here's the question. It says, sum of the roots of x squared plus x minus 380 versus 0. And that, if you're interested in watching the original solution to it, you will find that on day number 44. Day number 44. And the equation was x squared plus x minus 380. What I want you to do is, solve this problem yourself first, and then if you're interested in watching the solution to compare your work against the work that I presented, you will find that original solution that I did many days ago, many moons ago, on day number 44. Just type in Quantitative Comparison, 10th edition, day 44. You don't have to type in all of this thing, just type in Quantitative Comparison, day 44, and we'll pop right up, I guarantee it. I'll see you tomorrow, okay? Where we'll do this question. Bye now.